Hello. Okay, next. So I'm Rohit, and our project is Emergence of Skills. So the first paper is the theory of emergence of complex skills in the language model. So this paper explains how the mathematical how the emergence of complex skills arise in the large language model mathematical view. So first we define the what is emergence, and the theory of assumptions for emergence of complex skills, and then mathematical representation. So what is emergence? So when we train our LLM on a very large dataset and very huge parameters, it will learn complex things, and it can solve various problems that it never seen before. It's you in okay. So MRL ability to combine skills. So see the example: the city councilman refused the demonstrate a permit because they feared violence. Next. Huh. So we input LLM the close prompt questions. So we ask the LLM who feared violence, a councilman or demonstrator. Yeah. So it uses many skills like common sense and what is councilman and what is demonstrator. So the earlier model, when we ask this question, the earlier models they don't able to answer this question, but human can answer it. Human can answer is very clearly. So this is a cross entropy loss function which we used for training of LLM, and so model predict the word with higher probability in context of fast words, and we modify the cross entropy loss for scaling law. So to encounter the number of parameters and data size. So this is the modified loss. So the first one is the base model that basically humans understanding, and the next one is axis cross entropy, which is due to misunderstanding of the model and misprediction of model. Yes. Yeah, some theory and assumptions for emergence of complex skills. So this theory use a statistical framework, but it is able to proven generalization of unseen combination of skills, and scaling law is assumed here. And so it is so assumed pieces of text involve combination of random k tuple of skills. So it use k tuple of skills to predict the piece of text. So the above one is the piece of text, below one is the skills. So each skill contribute to some subset of uh, pieces to predict to some pieces of text. So nature picks some k skills uh, with probability. So the skills probability distribution is mu1 and mu1 and piece of text distribution is mu2. Yeah. So nature picks k tuples of skills with probability mu1 and use some random unknown process. We don't know the process and convert it into a text piece t with and assign it probability mu2. So assumption was here the model average error in the closed prompt questions into some constant is basically equal to our excess entropy cross entropy.
Yes, sir. There are we trained the LLM in thousand numbers of skills. So whether the new complex skills are emerged or not, to check these things, we give the close prompts
Questions.
and ask the LLM, and if and the errors of the output of these close prompts is equal to excess entropy. So here in the past, so they have modified the loss function with the new one. So and they define the see this 1.61 is the base because we cannot zero the loss, and other two terms are depend on the number of parameters and size of data set. So if we increase any of them, the excess gross entropy will be reduced. So if we reduce these two terms, the emergence of skill will increase.
Okay. Next. Yeah. See the illustration. So suppose nature produced this text t using the text, the whole text using 5 tuples of skills. So then this piece of text appears in the distribution. So 5C1 statistical task for corresponding to individual skills. So the single piece of text can be used to evaluate the 5 particular skills combination, and the 5C2 statistical task corresponding to pair of skills. Like 5C2 is basically 10. So each piece of text can able to evaluate the combination of 2 skills, and for the same 5C3 statistical task corresponding to triplet of skills. Yeah, next. Hmm. Yeah. So if the axis cross entropy loss is theta, then there are 1 minus alpha times n2 skills. N2 is basically the number of 2 combination skills. Model has at least so these these skills have at most beta theta loss on the task associated with them. See the example: if the axis cross entropy loss is theta, and then there are 1 minus alpha times n2 scales, and model has error less than beta times theta. Let's see here. So at least 30% less error. So here it is modified with probability mu1 and mu2. So with probability 1, the curve 1 minus alpha comma beta theta is given by this solution of this equation. And this is the plot. And
increase the number of skills. Here k is number of skills and theta is the cross entropy loss. If we cross entropy loss is constant, and if we increase the number of skills, then the graph is coming right and below it, which means the emergence is increasing.
this is a conclusion. It shows that reducing axis cross entropy loss naturally leads to emergence of both basic and complex skills, and this skill emerges without needing the model to.
Hmm.
Sanjeev Arora and Anirudh Goyal. Sanjeev Arora and Anirudh Goyal.
6 November 2023.
Can you just go? Basically, you are saying that basic and complex skills emerge. So initially, what are the tasks? Can you just go back to the task?
Task is to predict the next word.
So suppose we have trained the model. I have slides on it. So suppose we have pre-trained the model in different skills, and when we prompt it after training, it can merge some number of skills and emerge with new skills, new complex skills. And the marvelability of the compiled skills is emergence of skill. So how to check the emergence of skills? Suppose we have trained the model LLM in 1,000 number of skills, so we can, if we take any 5 set of skills, it will be like 10 power 10 to the power 15 number of different sets of skills. So we cannot check. We cannot create data set or something for checking each and every combination of the skills. So how we can do that? We can give the close prompts, which requires the different number, different skills which we have not trained, pre-trained for that particular skill. So here we can see the example: the city councillor can refuse the demonstrations a permit because they feared the violence. The question, the close prompt was who feared the violence, a councilman or a demonstration. So model requires so many skills like common sense. What is the councilman? What is the demonstrators? So model earlier than 5 years, they cannot predict this one. So because the number of parameters and data sets are low, so they go with 50-50. Like it can be a councilman or demonstrator. The maximum cross entropy loss is it can be log 2. And if we ask a question to the human, it will be very easy to answer. Human cross entropy loss will be log 1. Log 1 is 0.
who feared violence because that there was a wrong thing. It's not there based on this where what you're trying to question. If you go back to the paper, the question that was there like is a long sentence, then there is a good fear violence. Right?
I bet
So
this.
it's not it's just present from here.
But it's not incorrect, sir, because
So there is a context where I don't know. It's a new sentence who feared violence. I don't know. But the close one basically means that the sentence has both definitions of consumer and demonstrators. It's just that it's ambiguity. I can't say like whether consumer or demonstrators. There has to be a context in the sentence. There is nothing. So ambiguity is the sentence action. The main paper can just open up the main paper.
mm, it's,
Not
it's
just open a new tab. New tab on the if you have a new tab. Theory of theory of now search for that question.
3 of 6.
Who killed theory? Before that, there should be there was a okay, so that's the second. Just city councilman refused the demonstrators a permit because they feared violence. At the top of this, before that. Just before that, this thing you went listing the slides. And the question to prompt is basically follow on.
hmm,
I didn't see. Okay, it's there. It's not there. Over there.
so they take a reference from the different paper and change the cross entropy loss definition, and where the first one is the base, we cannot change that base, and the another terms are depends on number of parameters and the size of the data set, and we can change, and that's why we will call it access cross entropy. So these are the assumption, as we have talked about the scaling law. This cross entropy law is scaling law, and here the assumption was that like the piece of the text, like suppose the paragraph is predicted by some x number of skills. So to deep dive in the theory, suppose there are five number of skill and there are five number of piece of the text. So to predict the say one text or paragraph, there suppose there are three skills are predicting the same text. So what happens, LLM will take some x number of skills, like here we can see the five skills with the probability of mu1s, and assign the and the skills will assign the probability to a piece of the text, and at the end, with the text piece of the text will be predicted. Here I have seen. So the first term is base. We cannot change it, and the second two terms are called excess cross entropy, which is based on. Yes.
Just go to the experiment.
Emergence curve.
Emergence, okay, just emergence curve. Excess cross entropy of
Mu1 is the probability distribution of skills, and mu2 is the probability distribution in piece of text.
the skills are implicit, right? There are enumeration of skills.
Oh.
There is listing of fields.
No.
How are
Probability of each skill.
So
you to measure it out?
mm,
New one you can get from the model. How do you measure?
and skills are also theoretical part. We cannot see the skills in the models.
How is you to measure? New to the next slide. So you don't know.
Yes, I know.
What is the connection between this curve and mu1 and mu2?
So curve is k and theta
K is the number of
skills, and theta is excess entropy loss.
that means you that there's some way of tracking the skills, right? So how do they set K equals to? What does it mean to?
They give the close prompt, which requires suppose two number of skills, four number of skills.
How do you know the number of skills required for that close form?
It's not known.
Huh?
It's not known.
It's not known, but then how are they plotting K equals to in that curve? How are they plotting K equals to?
They are just going with that by increasing the k, how the emergence curve behaves.
If this is the K means they know the K, right? Person plotting the curve knows the K. But you're saying they don't know the curve K. They don't know K. How? Do you understand ever?
Yes, but
How did you plot K equals to theta equals 0.1? You're saying that no wait. Why are you skipping? It's complete now.
no.
Do you understand the paper?
Yes.
So what is so you're saying K as it increases,
Hmm.
curves are shifting to the right
And down.
and down. What is alpha?
Alpha is a number. Skills. Beta is the error, and alpha is I have written. So the speaker notes. Where's the speaker notes?
How many papers have you read? More papers you have.
One more is there.
Okay. But you have to be able to explain, right? I mean, you seem to be clear what is alpha, what is
लिखा जाता है वो वाला
what does it mean for curve shift to the right?
curve shift to the right and down. That means emergence of skills are increasing.
Emergence of skills is increasing.
Hmm.
As a function of what? What is influencing the emergence of skills? How much time you have to study on this kind of paper?
So much, sir, but I'm a little bit confused right now.
You are confused after.
No, that curve, how they deployed, I didn't think about that. I didn't got that
But that
question.
is the main essence of the paper. No? I mean, it's empirical, fine, but that is the main essence of the paper. What, I mean, what do you mean by, for example, theta equals 0.1, alpha is 0.2. So alpha is written here, beta is 3. So both alpha and beta is here. Or more than 1 minus zero point 0.2 fraction of scales, model answers incorrectly. 0.3 fraction of scales. This is values of scales. So 0.3 is what beta.
Alpha and beta is learning parameter, and the N2 is number of skills.
Greater than, more than zero point 0.8 fraction of scales,
Huh.
model answers incorrectly.
In 0.3 fraction. 0.3.
So that is what, go back to that. Now go back to the slide. Yeah. So beta error, beta is error. Error is actually a function of beta and theta. So for
The error is decreasing. So
more than as you go to the right, 1 minus alpha, which is more than 0.8 number of
What number of
one my
fraction of points, the model at k equals 2, let's say, makes mistakes, right?
hmm.
With theta, sorry, with beta.
So
Beta is not beta is a y-axis.
yes, beta is y-axis, alpha is x-axis. Alpha 1 minus alpha means the alpha is depends on skills. So alpha 1 minus alpha increases when skills as number of skills are increases,
As the
and
number of skills, so as the number of skills increases,
error decreases. So we can see say that the emergence of skill LLM is emerging the new skills.
so 1 minus alpha for, but when then for 1 minus alpha percentage of examples, so more than 0.8% of examples, it makes small error. Right? Go back to the we will add other slide.
Mhm.
Not the one before. One before this.
Uh,
For 1 minus 0.8 or 1 minus alpha fraction model answers incorrectly or makes mistake in beta error.
mhm.
Beta error is for greater than greater than 1 minus alpha fraction of skills. So the curve going down means as you increase the number of skills or increasing fraction of skills,
The error is getting number of errors is decreasing.
the model answers incorrectly in smaller number of
Huh.
smaller fraction. Right. So you should be able to explain like this, right?
But
Yes, go back. Go to the next presentation.
sir,
Next presentation.
so the next paper is task specific skill localization, fine tuned language models. So the problem statement of this is the localizing the skills in which part parameter finding which part parameters of the models are responsible for newly learned task for after fine tuning. So what is the key idea? So authors fine tune a model for a task and then use optimization to find the small subset of the important parameters. And by grafting only these few parameters into the original pre-trained model, and they achieve almost same performance as same as fine-tuned ones. Like suppose suppose we have a one pre-trained model and we fine-tune for a particular skill, and then we got the fine-tuned model. So what we will do, we can change the we can graph the model. What is the grafting? So if the we will check the single weights of both of the fine-tuned and pre-trained model, and if the difference is less than thresholds, then we will only take the base model weight. Otherwise, we will take the fine-tuned model weight. So here we can see the region where the weights are changing. Change in the weights are higher. So we will take that region in the grafted model. Otherwise, we will take base model weights. Hello. Mm. So in continual learning, if we want to make learn two skills to the LLM, uh, and we have two data set like for skill A there is data set and B for data set B, and if we fine tune first of all in A and then B, then model may forget the first one after fine tuning the second one. So this is called catastrophic forgetting. So what is the solution? Fine tune the model separately on task A and task B, and each time identify its graph region. And then to build a continual learner, apply a union both of the graph regions. Like we can learn the parameter like if the base model weight and
Okay, so I have some questions. I mean, I understand. You can go back to the. Multitask and container are the two applications, that's fine. So the baseline here is basically fine-tune model separately on each task, right? And that basically creates um, overfitting. So um, what is the exact grafting that is, what is grafting doing to avoid this overfitting? Can you go back to the formulation? Hmm. So what is grafting doing that is actually avoiding this?
What happens if we put binding of models? So a number of weights are affected by the binding is too high. So model forgets the different skills and overfit for that particular task. What we will do? We will check whether the change in the particular weight is less than our threshold. Then we will take the binding models weight. Otherwise, we will use base model. So after grafting, model is able to take again there its old skills. So it will not overfit.
Model will take its own skills.
So, so this is the base model, and this is the fine tune model. And see, these are the regions where the weights are used to only pre-trained model only. So this ratio is very low. We are changing only 0.01% of the weights. So it's always to lead to the output.
So these binary masks, are they set to be random or is there some logic in where they are set?
No, we will traverse full LLM weights. One by one.
Full elements. That practical?
So you are running the binary mask. Are you running the binary mask down?
Yes. So from the gamma, we will check whether the difference between the both the fine tune weight and pre-trained weight is less than or that's all.
Okay, I think you need to understand this paper much better, honestly. So, how much time did you spend reading this paper? Well, it's all about learning, right? Which you are completely missing in your answer. So you're making it sound as if it's a grid search. What is the point of learning? What is your project proposal?
Sir, I found the Microsoft paper.
You're not writing anything, you're not written anything about the project proposal. My request is this, I mean, Prateek, my suggestion is they just baseline one properly, do it properly. You know? And Sanjeev Arora paper may not be useful for baseline. That's the general understanding. Maybe if you think it's worth for them to just implement the grafting work as it is, will that be useful? Huh? They can just baseline it and see and analyze where the problems are. Let's start do some analysis. Right? So don't get into another paper. This paper needs itself because you have not understood that there is a learning going on with right the binary mass. Right? Prateek? So please focus on baseline. You can just tell them what to be.
So the paper has a lot of analysis. Let's go through those experiments, how they are analyzed, baseline them, and extra additional analysis is going to be how.
Okay, are we done?